Hello everyone and welcome back. My name is Mr. Kowald, and in this video I'm going to do a couple of practice problems involving finding the standard enthalpy, the standard change in enthalpy of a reaction using the standard enthalpies of formation. Okay, so the first problem is asking us to use the standard enthalpies of formation to determine the delta H, or the standard change in enthalpy of this reaction here. And so what we're going to be doing is we're going to be using this equation to help us calculate the standard enthalpy of this reaction. So the first thing we're going to need to do is we need to multiply the standard enthalpies of formation by the coefficients for each of the products. So let's start with NO. So we need to look up the standard enthalpy of formation for NO gas. So if we look that up, that we find is a plus 91.3. So it's a plus 91.3, so we're going to add that. So the standard change in enthalpy of the reaction is going to be equal to, and we have 4 NO, so it's going to be 4 times, what is it, 91.3. So 91.3, and that should be kilojoules per mole. So that's going to be kilojoules per mole plus, and then we have the water. So it's going to be 6 times whatever the standard enthalpy of formation for water is, and that's negative 241.8. So negative 241.8 kilojoules per mole. And so that's our two products. So add those together, and then minus that of the reactants. So we just do the same thing for the reactants. So we have 4 for ammonia, so we have 4 times, and we look up ammonia, and that's negative 45.9. So that's going to be negative 45.9 kilojoules per mole plus, and then we have oxygen. So then we're going to have 5 times that of oxygen. Now for oxygen, oxygen is an element, a pure element in its standard state. So this would be 0. So the delta H of formation, the standard enthalpy of formation, is going to be 0 for any elements in their standard states. So this will be 0. And so then all we need to do is just add this up, and the result should be the delta H of the reaction. So if we grab our calculator, and so what we'll do is we'll multiply 4 times 91.3. Make sure I got the sign right for, yep, it looks right. Okay, and then I'll add to that 6 times negative 241.8. Okay, and then we'll subtract from that 4 times negative 45.9, and then this is going to just be 0, so that's going to be 0. So we'll, oops, so we'll press equals, and here we get negative 900 and 2 kilojoules per mole. And so this should be the standard enthalpy of the reaction, the standard change in enthalpy of the reaction. And so if we look at our sig figs, this will be 3 sig figs. This is going to be 4 sig figs. But we're looking, since we're adding them together, we're looking at the decimal places. So it should be 1 decimal place there. And then, of course, we have 1 decimal place there. Here it's 0. So then when we subtract, we get negative 902. So this indicates that this is going to be exothermic reaction because of the negative. Okay, and then we can do the same thing for the second problem. Okay, so for the second problem, we're going to do the exact same thing. We're going to use this equation. And so this will be a little bit easier because we've got 2 elements in their standard states. So here we have solid iron. And so when we add these together, the delta H, the standard change in enthalpy of the reaction is going to be equal to, and then we have 2, so 2 times 0 is 0, plus, and we have a 1, so 1 times, and then the standard enthalpy of formation of iron 3 oxide is negative 824.2, so it's going to be negative 824.2 kilojoules per mole. Minus, and then we'll do the same thing for these 2 here. So the standard enthalpy of formation for aluminum oxide is negative 1675.7. And so it's going to be 1 times negative 1675.7 kilojoules per mole, plus, and then we have 2 moles of the iron, but we're going to be multiplying that by 0 since it's iron in its standard state. And so then if we add these together, we should get this becomes 0. This is just going to be, I don't really need a calculator, this is going to be negative 824.2 kilojoules per mole minus this, which is negative, so it's going to be plus 1675.7 kilojoules per mole, and then that's 0. And then if we're going to calculate this, oops, I made a mistake, so I need to switch these around. I put iron over here, so remember we're supposed to do products minus reactants. So I gotta switch these numbers around. So this should be negative 1675.7 kilojoules per mole. And then this would be 824.2 kilojoules per mole. And then these should be switched around. So this will be So let me switch these around. So this will be negative 675.7 kilojoules per mole plus 824.2 kilojoules per mole. And then when we add these together, you'll get, let's see, we get 1675.7 plus 824.2 equals, and we get a negative 851. So negative 851.5 kilojoules per mole. So it's a highly exothermic reaction because it's negative. So I hope you found this helpful. Thanks for joining me. If you like this video, share it with your friends. Hit the notification bell so you can get notified of any other videos I put out. Hit the subscription button and make a comment in the comment section so you let me know what you think and if you have any questions that you want me to answer. Thanks for joining me, and see you next time.